This prototype is all about the user interface, or UI. And one of the most common elements of a game's UI is the score display. A game is just a lot more fun when you can tell what your score is. So by the end of this lesson, the score will be displayed on the screen, increasing as the game progresses. UI elements like this score display work a little differently than anything we've done up to this point. You can't just position it where you want in your scene, like you might do with a 3D model. The text has to magically stay on top of everything else, at the same position on the screen, regardless of the camera's position or even the size of the game view window. To achieve this, we'll use something in Unity called the canvas. The canvas is this gigantic rectangle that you can see in scene view, which represents the screen display. And we'll use the canvas to make our score display look great. So, to make all that happen, I'll see you in Unity. We have the core mechanics of our game down, so when we press play, whenever we click on one of the objects, they disappear from the scene, and then if we let our objects fall off, they start getting removed from the scene because of our sensor. Now, to make this game even more interactive, we're actually going to create our first user interface to be able to actually get the score of our game. In order to do that, we're going to go to our project hierarchy. We're going to click on the Create button. We're going to go to the UI, and we're going to select Text Mesh Pro. Now, the first time you do this, it might ask you to import the Text Mesh Pro Essentials. So just make sure that you do that by clicking on the Import TMP Essentials button. Now, Text Mesh Pro has been added to our project. Now, Text Mesh Pro is a really cool feature in Unity to be able to add different user interface or UI elements, adding text to our games. So it makes it very helpful and easy to manage. One of the things you might notice you can kind of see, it's very difficult to see. In fact, Unity has, in our scene, added an entirely new element to our game. So you can see here, down in the lower left, that tiny little box is actually our game scene. And this massive rectangle here is actually where all of our different text and UI elements are going to be. In fact, if we actually drag this, and we'll make sure that we have our move tool selected, we can actually move this over to different parts of our screen. We'll just undo that for now. Now, all of our text and our UI elements are going to be rendered on this thing called a canvas. Now, this canvas is actually where all of our different elements are going to go. So if we add in buttons, or if we add in other text, it'll all be held on our canvas, which is the place where it manages all of our different UI elements. Now, with our Text Mesh Pro text underneath the canvas, we're actually going to rename this. So we'll rename it to Score Text. And you can see here that this has a pretty strange position on our scene, and we can move it around using our move tool, or we can do other things with our canvas here to be able to place our text in certain locations to make it easier. In our inspector for our score text, there's this little box on the left-hand side for our anchors. Now with the canvas, we can actually anchor our text in certain positions on the screen and base them off of those positions' values. It's particularly useful if you're doing something with different screen sizes. So for example, somebody might play this game on a phone, which is a very small screen, and it could either be horizontal or vertical. So it'll have different space on the side of your game. Versus in our current game scene, we can see the sides of the box pretty easily. But if we always want to make sure that our text is always in the top left, we can anchor our text using this anchors box, and it'll have you select different options. So in fact, you can immediately select, for example, I want my text to always be anchored to the top left of our scene instead of in the middle. And now you can see that the X and the Y positions have actually changed. If I go back to what it was by default, if I do the top left, you can see that it changes the X and the Y. If I move the text over to make it fit the scene, now you can see it pretty nicely. Just make sure we align that properly. So what'll happen is if I ever resize my screen, our text will always try to go to that position where we've set it in our canvas. So very helpful. So what you're going to do now is you're going to go into your hierarchy, right click, you're going to go down to UI, select Text Mesh Pro, Text. Once you've selected that, it will probably prompt you to install Text Mesh Pro, so make sure you do that if you haven't done it before. Once it does that, you will then have a canvas object, and underneath the canvas object, if you expand it, you'll see score text. Just make sure that you rename the text element to be score text, and then go into the rect transform component, select the anchors, and you're going to select the top left anchor preset, and then just make sure that you reposition your new text to the top left corner using the move tool, so that way it's always bound to the top left corner and it's not just awkwardly sitting in the middle of your screen. Now it's your turn. Now we've added Text Mesh Pro to our project and we've created our score text and repositioned it. Now other things that we can do with our Text Mesh Pro elements is we have this section down here. And we can actually change the text. So what it will set it to be for now will just be score : and keep track of the score. Under main, make it really tiny. And then if you want to, you can change the vertex color. So actually if you just click on the white box, you can actually change the color of your font too. So if you want it to be red, like bright red, or really dark black, if you're on a white background, whichever one. But I think white is totally fine for now, so we'll just leave it for white. So what you're going to do is you're going to go to the score text, change the text in your text box to be score radio button, to be whatever size, and selecting any one of the different colors. So in our project, we've set up Text Mesh Pro and added a text element to our scene, so that way we can actually keep track of our score. Now what we're going to do is we actually need to use code and a variable to keep track of and update this score text whenever we need it. To do that, we're going to go into our game manager script. Now, one of the first things that we actually need to do in our script is we need to take advantage of these using keywords up here. Now, this entire time, as we've been doing our project, we've had these statements at the top of our program the entire time. Using is a special keyword in C# that enables you to import other libraries and packages into the current script that you're editing. It's particularly useful in cases where you import other libraries that you weren't initially using before. In our case, we've been using some of the standard C# libraries that we've needed, as well as we've actually been importing all of the different Unity methods and classes that we were using before. Different things like game objects or mono behavior. Since we're using TextMesh Pro, we actually need to import another package to do so. So we're going to type in using and then TM Pro. So now our project will be using all of the different classes and methods for TextMesh so that we can actually interact with them and control our user interface. At the top of our class, we're going to declare a new variable. So this will be public. So we can assign it in the inspector. It'll be a TextMesh Pro UGUI, and we'll call it the score text. So this will be the text that we created before. On top of that, we'll need an actual variable to store our score. So it'll be a private, it'll be a whole number, so we'll make it an integer, and then we'll call it score. In our start method, we'll make sure that we set score to 0 so that TextMesh Pro won't have any issues in using it. And then underneath that, we'll actually use our score text variable. And in this case, we actually have to use the text itself. So we actually have to use .text to be able to set the text. And we'll set it to be score as a string literal, colon, space. And then we're going to concatenate, in this case, our score variable. So as we update the score variable, it should change later. Now, in Unity, make sure that in your project hierarchy in the game manager, you assign the score text underneath the canvas into the score text in our game manager script. And now when we save, press play, you can see that our score is immediately set to 0. So what you're going to do is in your game manager script, at the top of the script, add a using TM Pro underneath all of the other using statements. For our variables in our script, we're going to create a public TextMesh Pro UGUI, as well as a private integer for our score. In our start method, we're going to set score to be 0, and for our score text variable, we're going to get the text element, and we're going to set that to be score colon, and then concatenate on our score variable. Now it's your turn. We've set up our game now so that our score text can actually use the score variable that we have in our game manager, but it doesn't actually do anything, so we're going to add in ways that we can actually update our score. In our game manager class, we're going to create another function so that we can actually update our score and then update our score text accordingly. If we create a new method, we'll make this void for now since it's just calculating our score and then updating something already. We don't need it to return any values. We'll call it update score. And then in our update score, we're just going to take out our score text where we update it here, cut it, and paste it into our update score. Now, every time we call update score, it's just going to tell us our current score, which isn't really that useful since our current score is 0 and it's not actually doing anything. So we're going to use parameters here so that we can actually add to our score every time, and then that way it'll update the score text here. So we'll use an integer and call it score to add. So this will be the score that we add into our current score every time. Now we need to actually update the score itself before we update the text, because that's what the text is using to actually change the score. So if we type score, and then we say plus equals the score to add, now it'll add whatever value we pass into our parameter onto our score, because remember, this is the same as saying score is set to score plus score to add. So the original score that we had plus the value that we pass in here. So now it should update score. So now if we go to our start method, we should say update score. And we're not adding anything because it's the first time it's running. So it should just tell us the score, which should just be 0 anyways. So if we play our game, you should just see a 0. Cool. So we know that works, but we still need to update it. So I think a good place to update our score in our game manager is probably whenever we spawn a target, at least just for now, just to see that it works. So in here, every time we spawn a new enemy, we'll update our score. We'll just say 5 every time. So every time one of those blocks spawns, it should just add 5 to our score. So if we test this in our game, cool. So every time one of these blocks spawns, it adds 5 to our score every single time. So works for now. So what you're going to do in your game manager class is you're going to create your own update score method and pass in a parameter for the score to add. And then you're actually going to use some calculations so that we can take our current score and add in the score to add onto it already. And then using the line of code that we had in our start method before, we'll set our score text to be score concatenated with the new score that we updated. Now when you start the game, make sure you call update score and just pass it a 0 because we're not adding anything to it. And then just to test it out, in your spawn target method, add an update score call and just pass it the number 5 so that when you play your game, you should see it update too. Now it's your turn. Now, we've set up our code so that we can update our score through a method, but the problem is that our score is just updating every time an object spawns, which could be fine for some games, but in this case, we want to actually update our score when we click on one of the boxes. So, we're going to change that in our code. Now, in our Game Manager class, this could be one place where we actually create our code to be able to figure out which one of our targets we're spawning, and then accordingly assign points as a result to update our score. Another Another way that we could do this is by communicating what we're trying to do in our game manager script. What we're actually going to need to do is get a reference to our game manager script that's attached to the game manager already inside of our scene, so that way we can get the live data as it happens. To do that, we'll need to game manager variable. Let's see, update score. So the problem is, because update score, I click updates by 5. In your start method, you're actually going to set that to be 5. In our second script, now if we play our game and we press play, we should see different point values. We could check by name which object we're actually assigned to right now. So for example, if it's that first crate, then click int for your point value. Now it's your turn. Our score is now perfect and ready to go. So each time we click one of the different objects that spawn, it gives us a different number, which is a lot of fun. You can see the score updates, but it definitely doesn't look or feel that cool when you click on the different ones. So we're going to up the coolness factor by a lot by using some particle effects. In our target script, we're going to create a new public variable so we can assign it in our editor. It'll be a particle system. And we'll call this the explosion particle. Now we want to make sure whenever we destroy one of our objects, we use our explosion particle. So in our onMouseDown method, we're going to create a new explosion every time we destroy the game object. So we can actually instantiate our explosion particle. We'll set the position to be the position that our current game object is at. And we'll just set the particle to be at the same rotation that it was at before. Now, in Unity, just make sure that on each of the different prefabs, you open them up, and we need to assign them each explosion particle. We actually get blue. A little bit cooler. System, variable. We've added a score display to our UI, but there are other critical UI elements we need for a fully playable game experience. Right now, when the player misses an object and loses, nothing happens. They just get to continue playing, racking up score, even after they've lost. So by the end of this lesson, when the player loses, a game over screen will appear. When the player clicks the restart button, everything will reset, and they try it all again. Now, we've programmed a lot of things before, but to this day, we've never programmed a button. We have to make the game restart when the player clicks the restart button. So here's how we'll do it. In our game manager, we'll write a new method called restart game, and that will reload the entire scene. It's basically like very quickly stopping and restarting your game. Then we'll add something called an event listener to that restart button, which will call that restart game method if it's clicked. It's called an event listener because it's carefully listening for that clicking sound. As soon as it hears it, it'll run whatever code we tell it to. Buttons really can be excellent listeners. So to make all that happen, I'll see you in Unity. Now we have it so that whenever we play our game and we click on any of the different objects, you see we gain score. But eventually what I want to happen is whenever we miss clicking one of these objects or we go to say a negative score, we actually get a game over. So we're going to set that up really quick. In our canvas, if you right click on it, go to UI, and create a Text Mesh Pro text again. We'll rename this the Game Over text. And now that it's renamed, let's change the text in the actual box. Under our text box, now it says Game Over, cool. Now let's make it a similar font to what we had before. Now it's really hard to see, so I'm going to actually make the font larger. So now you can see it's a bit bigger. If I even bold it a little bit, it has some thicker lines. And it's really hard to see against this white background, so I'm going to change this to be like a dark red. There you go. And you can see that it has this weird issue where the text is kind of filling outside of the box. So one thing that we could do is we could actually change the width and height of this rect transform so that it actually covers this entire text. But instead, I'm actually just going to use my different settings for the text itself. You see there's all of these different options, so we can actually set it so that way it's center aligned. So this is nice, that way our text will always be within the center of our text box. And then what we can do is, you can see here wrapping. So if we actually disable wrapping, this means that our text will no longer be wrapped. One thing that your text to icon, it just turn. Now we have our game over text for our player, and we actually need to be in, which is good. That's exactly what we wanted. Exactly what we want. See that now our text box, and I can see that we can text, and then that we can set name. Set the cool game over text in your hierarchy inside of Unity, and then in your start method, just to test it out, we're going to set that game object to be active again, so that way when we play our game, it should just pop up on the screen. Now it's your turn. When we play our game, you can see that the game over text just pops up, which is definitely no good because we've immediately lost the game. So we're going to set it so it only pops up when one of our good objects hits our sensor at the bottom. So in our game manager script, we're going to create a method to be able to call setActive whenever we need it to. So underneath where we update the score, so we'll create another public method because we'll actually need to use this outside of this class. Make it a void so it doesn't return. Perfect. So now we can call. So what we're going to do is we're actually going to find the bit of code where we collide with our sensor bar at the bottom of the scene. And this is actually where we'll call the game over. And we'll game over to pop up whenever. We'll call this one just. Hits the sensor, then it will trigger our game over. But we don't actually want that to happen. What we want is whenever use the game over. You know why that happened? Because I forgot to save my script. I'm going to create another public method for game over, and then we're actually just going to So we have our game set up, so whenever one of the boxes falls to our sensor, the game is over. And game over. Cool. But we do have this problem still where we can, in fact, still spawn objects, and we can actually keep gaining and losing score, which is definitely not something we want to happen. Kind of defeats the point of high scores if you can keep gaining the score after your game is over. So we're going to fix that. So we're actually going to go into our game manager class and we'll create a Another public variable, so we can actually use this spawn target. Okay, nice. So now we have the object spawn again. So let's just see, and then it goes into another thread or can't figure out routine. So now all of our variables in spawn target, you can now change that true variable from the while statement to is game active, and then because the game is never actually ever set to active according to this coroutine, then it actually just doesn't even spawn any enemies. So always make sure, especially, to update your variables and set them before you ever have We have our game over working perfectly now that we fixed that bug. So we can have one of our objects go to the bottom, game over, object stops spawning. I can't click this box. Very frustrating. Now, we have no way of replaying this game now that it's over, so I guess the game just ends. Well, that's not a good thing to do. So we'll actually add a way that we can restart our game. So we're actually going to create a button, our very first button, and we're going to do that on our canvas. So if we right click on our canvas, go to UI, actually need to zoom out like button. So we're going to text of our button. So we'll change radio button, this little circle on the right side of our inspector. And it gives us options of different, too large there. As soon as I change its, and then now we have our button set up in our game, but we actually need to use this button to tell our game to restart when we click on it. Now, in our game manager is actually where we're going to tell our game to restart our game. Now, the way we're going to do that is actually through managing our scenes. So, we actually need to use another library, very similar to how we used our Text Mesh Pro library to be able to interact with Text Mesh Pro elements. So in this case, we're using Unity Engine because our scene management is under the Unity Engine library. And we're actually going to grab specifically the scene management library itself. And so this will actually enable us to interact with and manage our scenes in our scene folder. Now, we're going to go to the bottom of our game manager script and we'll create this method underneath game over. So we'll call it public so we can use it outside of the class void restart game. And then this is actually where we're going to reload our scene. So we can actually use the scene manager class and we'll load a scene. And in this case, we could use the name of the scene, which I think was Prototype 5, or we can use code to just tell us and make our lives a little bit easier. So scene manager dot get active scene. So this is the scene that is currently active for the player. And then we actually need to get the actual name of that scene. So this handy little method over here, this line of code, using our scene manager that we just import on your phone or on a website where you can click on them in Unity and they'll do something. Fortunately, we're just reloading the scene that we're currently using. So we got the name of our current active scene and our scene manager actually knows which one is the current scene. So we make sure we save this. So our buttons work very similarly to how buttons would work on your phone or on a website where you can click on them in Unity and they'll do something. Fortunately, buttons are already configured to do that. So they actually use this onClick method, which is very similar to how on our different prefabs, whenever we do the on mouse down, we can destroy the objects. So specifically, our restart button knows when we've actually clicked it itself. You can see there's restart game. So now, if we management, so that way we can actually manage our scenes. Load them in. Once you've added that library, you can go and add a new method. Make sure it's public so we can use it outside of this class. It'll be void and it'll be called restart game because it'll be restarting our game. We're going to get the scene manager class. Now that we've used the scene management library, that class will actually let us use the load scene method, which in this case will be taking in a string, the name of the scene that we want to load. And in our case, we're going to reload the current scene we're using. So our scene manager knows which scene is currently the active scene, and then we can actually grab the name of that scene, which will give us the string. And then the drop is clicked. Now it's your turn. we can this button going in game manager restart. In fact, X's and skull when in our variables, we're going to get that game object and we have the UI for our score during the game. We have the UI for the game over at the end of the game. So now we need to make this experience fully playable by adding a UI for the title screen at the start of the game. At the start, you need the title text, of course, but you also want to give the player a menu with options for how they can experience the game. More specifically, how difficult they want the game to be. If you have an easy, medium, and hard setting, your game can be fun for a lot longer. Users can start off easy and graduate to more difficult settings, testing their skills. So by the end of this lesson, you will have a title screen with 3 difficulty buttons, where the easy setting will make the objects spawn slowly, but the hard setting will make them spawn faster. To make these buttons function, we're going to do the most advanced programming we've done yet, but don't worry, you can handle it. When one of these buttons is clicked, the button listener will call a set difficulty method. That set difficulty method will take the difficulty value and communicate it to the game manager script. And in the game manager script, the start game method will take that difficulty value and use it to alter the spawn rate. If all of that sounds complex, that's because it is. But this is the last lesson of the final prototype. You've come all this way, and you're ready for it. So, to make all that happen, I'll see you in Unity. Now, we just need to add a few more UI elements to our game. So we've made it so we can restart our game, but we want to be able to set the difficulty for our players. To do that, we'll actually just duplicate some of our text and our buttons, so our game over text, since our title will be in the same place. If we select our game over text and duplicate with Control D, we have game over text again. We'll set this to active, and I'm going to rename the text to be our title text. And then we don't want our text to be the same as our game over, because that would be really confusing. So what we'll do is we'll change our text and we'll come up with a clever title. So I'm gonna call this Clicky Crates. Now I don't want it to be red, so I'm going to change that and we'll make it the exact opposite color. So that'll be, let's see, maybe a greenish, maybe a bluish. Ooh, I like that blue. That one looks good. Maybe a little darker. There you go. Cool. So now we have our Clicky Crates. Now what we also need to do is make some more buttons. So we'll actually take our restart button and we'll duplicate this. And we'll set this back to active so we can see it. Now our restart button, this one will be our easy button, because we definitely want to start easy first. And then we go into our easy button by expanding. We'll change our text because we want to make sure that we know it's easy mode. Easy. Now our button is definitely a little bit too large, so we'll actually change the width to make it a bit smaller. We'll make it something like, yeah, something like that. Like this is a nice round number so it's easier. So 115, cool. And then we'll reposition this, so let's see if I move it not on the Y. In fact, I want it to move on the X. So we move easy over to about there. Cool. And then let's see, so we want to do the same thing. We'll make a medium difficulty button, so we'll duplicate that. That time I just right click duplicated. Call this medium button. We want to rechange the text back to medium this time. Now the problem here is our button is actually on top of our easy button, so we can't actually see that. So let's see. Let's put this. What happens if we put it to 0? Okay, button's a little tree. On our hard buttons to press, they don't really do anything right now. Put them all to active so you can see. Now we've added all of our buttons and our title text to our game, but these buttons don't actually do anything, so we'll need to create a script to do so. One thing that we're going to do is just some cleanup. So in fact, because we copied that restart button and duplicated it, if you go to the on click, if you select one, One of the buttons in the is we're going to actually select all of our different buttons, and we're going to scroll all the way down. Now I'm going to add a component, and we're going to actually search for that difficulty button script. There you go. Now move the reference to the game manager on each of your different buttons. You're then going to create a difficulty button script, and then make sure that you attach it. On each of our buttons, we've now applied scripts to them, and now we actually want to use a method so that way our buttons know what to do. Now, in our difficulty button script, we're going to create a new method. This one we'll just make private, so we'll just say void set difficulty, because I don't believe we'll need this later. We'll just need it inside of this class. And then for set difficulty, we're just going to test and see if it works for now using a debug.log method. So that way we can print out to our console in Unity. And we're actually going to get the button .gameObject.name. So this will give us the name of our button. And then we'll use a literal string to say was clicked. So then when we press one of the buttons, for example, it should say easy button was clicked. And then one thing we do need to do is we actually need to use this method to see when a button was clicked. So we can actually say button encode clicked click event. Is click on button. Now similar to what we had with the restart button, where it had an on click method to listen for when the button was clicked by the mouse, we can actually use that encode, so we can actually use on click. So when the button is clicked, we need our game to listen to pay attention to when it's actually been clicked. So in this case, in programming, we call this adding a listener, so that way it pays attention for when a certain event has happened. In this case, a click event. And then we can just use a method to pass into our listener, so we can actually just use our set difficulty method to detect hard but our listeners were set up properly. See that our start method method, you're going to make sure you add a listener to your button for the on-click event, and it should trigger. Now it's your turn. Our title screen is now looking amazing, but we do have this problem where we're not actually starting the game. The game has already started, and we can actually click all of these boxes, but in fact we can also click these buttons, which is helpful. And down in the bottom you can see the game has already started. That's fun. Like restarting and game over. We'll add a so we can use it for our game. These, just like we did, we'll get our game manager variable and we'll set it find, and we can use, which is handily also called the game manager. And then in our set difficulty method, none of those go. If we test what to do in the code from our start method at the top and paste it down into start game, in our difficulty button, in script, create a variable for the game. Our game is so close. Make sure to right click and drag them into our title screen so that they're nested as child objects. And disable it when. So now it's your turn. So our game is just about there. We have our title screen. We can click on one of the buttons. We have all of these objects that spawn. We lose the game. We can restart, reload our scene. We get our title screen again. The last thing we need to do is actually make these difficulty buttons work, so then our players can have a little bit of fun. In our code, in our difficulty button script, we're going to create a public variable so we can assign them. Hard will set the difficulty to 3. Difficulty parameter so that it will use this integer. And then, lucky for us, because we actually made a spawn rate before, we can actually now we'll do 1 second and our difficulty. So 1 buttons, half can rate, / in our difficulty button script, start game is little unders. Before press, it'll send in that difficulty to start game, send that information to our game manager, which will then use that updated spawn rate to spawn enemies faster or slower. So now we're really communicating between the different scripts that we've written, very similar to how we were learning how to. In our game manager script, This is a very exciting moment. We've worked on these projects for all this time using those, let's face it, kind of boring primitive shapes. It takes a lot of professionalism. Alright, welcome to Challenge 5. So, let's review the project that we made. So, I'll press play, we'll enter our play mode, so I can select one of these different options for my Clicky Crates game. So I'll choose easy for now, keep it nice and easy. Click the boxes, don't click the skulls, those are bad. We have the score that updates. No, the skulls, why? Okay, so our box runs out of the view. Our game over pops up, we can restart our game. Let's do hard mode, let's see how many we can get this time. No. Oh, we missed one. No. Oh, it's so difficult. Okay, so then we can change our difficulties and then we can restart our game. So, cool. So we have all the different boxes and skulls that got the big old whack of food. Here, I like these buttons are probably better than mine. They're so much more visible, so I like that. Click the pizza instead. Okay, cool. Pizza. Skull, do we click that? Okay, click the skull, click the pizza. Okay, oh, so this is very similar to our last game. We're clicking things, but we click the pizza instead. Okay, cool. Pizza, more pizza. Cookies. So this is a food-based game. Don't click the skull, click the cookie. Do this wall. This is happening. We have our timer, so we can click all the different foods. This is cool. Almost hard. I do not like the looks, and hard is definitely very hard. It's very difficult. So let's see what we're working with. Our starter project here, and already I do not like the looks of what is happening. So, okay, I'll press play. So all of our buttons, it's so bad. The easy is all the way on the right, the hard's all the way on the left, the medium is off center. Oh man, this is a nightmare. Okay, let's do easy again. We'll keep this easy. There's no timer this time. What? I lost already? There's not even a restart button? Okay, let's try that again. So there's no timer. All right, so let's try this one more time. Let's see if we can see what's happening. We'll press the easy button. Do we even get a score? Pizza, food. Oh my gosh. Oh, it's destroying when we mouse over. I don't even have to click. Well, that's kind of cool. Okay. Oh, I missed one apparently. Oh. Okay, so I think we have a general idea of what's happening here. So, for your 5th challenge, we have a whole slew of problems. First, as soon as the player starts the game, our difficulty buttons look really messed up. We need to fix that for sure. None of the text is centered, so it looks very bad. Our second problem, our food is being destroyed too soon, which might not really be a problem, but we'll say it's a problem for now. So instead, the food is destroyed when the player masses over it, which is fine for the food, but probably not okay for the skull in retrospect. So we need to make it so that everything's destroyed when we click on it. Our score is being replaced by the word score. We don't even have like our bonus challenge in action. If we play our game, you can see that I want to take. So, the bonus challenge, if you need, is that helpful little video. So,
you.